Motors haven't changed in over 100 years. If you look at a motor that's in a museum and you open it up, what you'll see in front of you will look a lot like any motor that you open up today. It's iron with copper wire wrapped around it. So what's the problem with that? Well, one of the issues is reliability. One of the ways these motors fail is that copper wire heats up and cools down over time, and those wires rub against each other. Eventually, those copper wire windings fail. The other failure mode is that insulation within that motor. The copper expands and contracts at a slightly different rate than the iron, and that causes the insulation to wear and eventually causing a catastrophic failure. One of the sources of losses is that iron core, and we've eliminated that, allow for a higher efficiency motor. So how do we do this? Well, we start with eliminating all the copper wire and iron core and replace it with a simple PCB stator. Instead of copper wire, we etch out copper on a printed circuit board. We eliminate all the iron, and that drastically reduces the size and weight of the stator. We also utilize 66% less copper than a conventional copper wire wound stator. All of this results in a more reliable motor by eliminating the two failure modes previously described. So what does the motor look like once fully assembled? Well, in this image here we show two comparable stators. On the left-hand side is our founder's son, Drew, trying to lift a conventional 1 horsepower AC induction motor stator. It weighs over 20 pounds, whereas ours weighs less than 1 pound. And when you put the whole motor together, a conventional AC induction 1 horsepower motor weighs over 35 pounds, whereas our 1 horsepower weighs less than 10. So there's dramatic improvements in size and weight. To summarize, we have 6 key differentiators with our technology. First, higher efficiency both at full load and partial load. Second, we have a lighter weight and smaller size, higher reliability, and we haven't touched on it yet, but you'll soon see later in this presentation our integrated VFD, which results in a lower total cost of ownership. And finally, lower sound and vibration due to the elimination of cogging torque.